right, so page 208, number 11. They are asking us to write or graph the rational function that has vertical asymptotes at x equals -3 and x equals 1, and a horizontal asymptote at y equals 3. So we have to work backwards in the process that we've been doing. So what do I mean by working backwards? Well, let's just talk generally for now. Let's say that we had a quadratic ax squared plus bx plus c. We know that we need to find the roots of the denominator to find the vertical asymptotes. If our denominator was a quadratic like this, to find the roots, we set it equal to 0 and we solved. One of the ways to solve a quadratic is by factoring it. So if we factor it into two binomials, let's say x plus a and y plus b, right? Excuse me, not y, just x. Go back. X plus a and x plus b. So we factor it into those two binomials. Then we would take each of those factors and set them equal to 0. Boy, I'm all over the place. And then we would solve it, and we would get x equals like a or negative a, and x equals negative b. Well, we have to do the reverse of this, right? They are giving us what x equals. So they're giving us the end part of this process, and we now need to work backwards. We need to take the vertical asymptotes and write them as simple equations. And then we need to take those simple equations and write them as a multiplication of two binomials, and then we actually have to multiply them to get our quadratic. So let's actually do it. All right, so we take x equals -3, and that becomes x plus 3 as a factor, and that would equal 0, but we know that we're more interested in the factor of it. And we have x equals 1, which would be x minus 1 equals 0, but again, we're just more interested in it as a factor. Now we FOIL those together. X squared plus minus x plus 3x minus 3. Combine like terms, x squared plus 2x minus 3. So we know that that's our denominator right there, because it came from the vertical asymptotes that they gave us. So that'll be our denominator. Now we need to think about what the numerator is, and that's where the horizontal asymptote comes into play. Okay, y equals 3. Well, we have our three cases for the horizontal asymptote. The first case is if the numerator is less than the denominator, then the horizontal asymptote is y equals 0. Well, obviously, our horizontal asymptote is not y equals 0 in this problem, so it's not case 1. Our third case is when the numerator's degree is greater than the denominator's degree, and in that case, there is no horizontal asymptote. So obviously, this problem is not case 3, so it's case 2. And in case 2, when our degrees of the numerator and denominator are equal, then our horizontal asymptote y equals a over b, where a and b are our leading coefficients. Well, this makes sense here because y equals 3 can be 3 over 1. So a is 3 and b is 1. So we know that our degrees in the numerator and denominator have to be equal. And we just found out the degree in our denominator. So that means the degree in the numerator has to be 2 also. And we know the leading coefficient has to be a 3 in the numerator and a 1 in the denominator, which it already is right there. So we can now say that our function, let's call it f of x, there's our denominator, x squared plus 2x minus 3. Our numerator has to have the same degree, and it has to have a leading coefficient of 3. So that's the simplest form of what this function could be. It could be others because we could play with this and say plus x plus 3, right? We could change the numerator to a lot of different things. We could say minus 2. We could tag anything onto that numerator quadratic, and it would still work. But we don't need to plug anything onto it. We can just go with that right there. And then obviously number 11 asks you to graph it, so you would go through our process of graphing it. Graph the asymptotes, use your calculator, find where the curves are, draw in the curves.